Okay, we are going to officially and formally learn how to use an area model today. Now, if you have been doing your iReady and you have been watching the videos that I've already made, this should not be anything new to you because I've already explained it, you've already done it in iReady, but we haven't formally looked at it yet. So I'm going to show you the hows and the whys so that you can do it yourself. The area model is really important because it still uses partial products, but it's really easy to do very large numbers. So you can do 4 digits by 5 digits. It's also used throughout high school. You're going to use it a whole lot in algebra. So make sure you understand the steps. Make sure you understand how and why we're doing this. Let's start with the reason why it's called an area model. You might remember back in 3rd grade when you found area and perimeter. And if you remember, finding the area of something means that you are finding how many square units fit inside. And you could find it by multiplying length times width. And we're going to do the same thing with our numbers. We're going to use this to help us find the products of large numbers. And I'm going to start with just a real basic one. Let's do 57 or 56 times 7. And I'm going to do the same thing we've been doing. I'm going to look at my numbers and I'm going to decompose them. So I'm going to start with the 56 and I'm going to say that's the same as 50 plus 6. And my second term over here is just a single digit, so it's going to go on the right times 7. And since I have two numbers here, I'm going to split that into 2 columns. And this is my area model. It's going to give me my partial products and help me to solve the problem. So when I look in a cell, I have to look all the way to the left and all the way to the top to see which two numbers to multiply. So you can see in this cell, I'm multiplying 50 times 7. And think about what we did back in September when we were multiplying with zeros with base 10 numbers. I'm really thinking 7 times 5. I know 7 times 5 is 35. And since this is 5 tens, this needs to be 35 tens, or 350. Then I need to look at this cell, and I always again look all the way to the left and all the way to the top. So I'm going to multiply this times 7 times 6. And I know that that one's 42. And if you don't know, use your multiplication chart right now. Now I can add these two partial products mentally to see that it's 392. But if you're not sure, come over here and just line up your numbers by place value. And there's your 392. Okay? So I can do a second example there. I've lost my track here. All right, I'm so used to Google Slides right now. So a second example I want to use is, let's do a 3-digit number, 218 times 5. We're going to do the same exact thing. We start with a rectangle, and I'm going to decompose my large number into 200 plus 10 plus 8, and I'm going to multiply it by 5. This time, since I've got 3 numbers, I'm going to turn it into 3 columns. And I'm going to do 5 times 200. So I'm thinking 5 times 2 is 10. But since it was 100, this also has to be 100. So 200 times 5 is 1,000. And then here I look all the way to the left. 5 times 10 is 50. And here, all the way to the left, 5 times 8 is 40. And again, these numbers are nice. They can easily be added mentally. 1,090 But if you can't do them mentally, just come over to the side and line them up by place value to get your 1090. Okay? Now, let's look at a bigger and better 3-digit number. Let's do something like 316 times 27. So this time we have 2 digits there. We always start with our rectangle. In our first term, we're going to decompose. And when you decompose, you always break it up into just basic facts. So 316. 16 is not a number I would know how to multiply, so I don't want to break it up into 300 plus 16. I want to break it down by every place value, hundreds, tens, ones. I'm going to do the same thing over here with my 27. 27 decomposed is 20 plus 7. Since I had 3 numbers here, I want 3 columns. And since I have 2 numbers here, I need 2 rows. And we're going to do the same exact thing, only this time we have 6 partial products instead of 3. So 20 times 300, I'm thinking 2 times 3, and that's 6. But since this was 2 tens, I need to make that 6 tens. And then this was 300, so I need to make it 60 hundreds, or 6,000. I'm going to do the same thing here. Look to the left to get 20. To the top is 10. 2 times 1 is 2. 2 tens times 1 10 is 200. And then in this cell, I look to the left to get 20. I look to the top to get 6. 2 times 6 is 12. And since it was 2 tens, it's going to be 12 tens. So those are my first 3 partial products. I'm ready for my bottom row now. And I have 7 times 300, so I'm thinking 7 times 3 is 21. 300s means this has to be 2100. However many zeros appear in my factors has to equal the number in the product. I'm going to look to the left for the 7, the top for the 10. And then over here, all the way to the left, I have a 7. All the way at the top, I have a 6. So 7 times 6 is 42. Now, these are definitely not products that I can add mentally. And because I don't want to make any mistakes, I'm not going to try to line those 6 numbers up. I'm going to do them in sets of 2. So I'm going to, I could do those mentally, but I'm going to come up here and say 6,000 plus 200 plus 120. And it's really important that you keep your place value lined up. That gets me 6,320. And then down here, I've got my 2,100 plus 70 plus 42. And again, all those place values have to be lined up. And I have 2,212. So I'm going to take this, add it to that. That's my top row added to my bottom row. And I get the product of 8,532. In person, I would practice with you a lot more on this. My tape doesn't last that long, so please stop it, rewind it, copy these in your notebook. Make sure you understand the model quite well before you go and try to do your practice activities.